This video explains Taylor and Maclaurin series. Taylor series. Assume f of x has a power series representation about x equals c, where c equals the center. So in order to understand Taylor series, you need to understand power series. So what is a power series? A power series is an infinite series of the form the summation from n equals 0 to infinity of a of sub n times x to the n, where n is a positive integer. Taylor series are represented by f of x equals the summation from n equals 0 to infinity of a sub n times x minus c, the center, raised to the n power. So c equals the center and a sub n equals the coefficient. A sub n equals the nth derivative evaluated at the center over n factorial. F of x is represented by a sub 0 plus a sub 1 times x minus c plus a sub 2 times x minus c squared plus a sub 3 times x minus c cubed plus a sub 4 times x minus c to the fourth, and so on. Maclaurin series are simply Taylor series centered about x equals 0, so c equals 0. They are represented by f of x equals the summation from n equals 0 to infinity of the nth derivative evaluated at 0 over n factorial times x to the n, where a sub n equals the nth derivative at 0 over n factorial. Maclaurin series are represented by f of x equals f of 0 plus f prime of 0 times x plus f double prime of 0 over 2 factorial times x squared plus f triple prime of 0 over 3 factorial times x cubed plus the fourth derivative of f evaluated at 0 over 4 factorial times x to the fourth, and so on. So now let's try an example. This example says, write a Taylor series for f of x equals sine x centered about x equals 0. So notice that this is a Maclaurin series because the center is x equals 0. So we're going to start by taking derivatives of the function f of x equals sine x. So f of x equals sine x, f prime of x equals cosine x, f double prime of x equals negative sine x, and so on. Then we're going to evaluate each of these derivatives at x equals c, the center, or 0. So f of 0 equals sine of 0, which equals 0. F prime of 0 equals cosine of 0, which equals 1. F double prime of 0 equals negative sine of 0, which is still 0. F triple prime of 0 equals negative 1, and so on. So now using these values, we're going to find a sub n. So remember that a sub n equals the nth derivative over n factorial. So a sub 0 equals 0 over 0 factorial, which equals 0. A sub 1 equals 1 over 1 factorial, which equals 1. A sub 2 equals 0 over 2 factorial, which equals 0. A sub 3 equals negative 1 over 3 factorial. A sub 4 equals 0 over 4 factorial, which equals 0. A sub 5 equals 1 over 5 factorial. A sub 6 equals 0 over 6 factorial, which equals 0. And a sub 7 equals negative 1 over 7 factorial. So using the formula given at the beginning of this video for the general form of a Taylor series, you're going to get f of x equals 0 times x minus 0 to the 0th power plus 1 times x minus 0 to the 1 power plus 0 times x minus 0 squared minus 1 over 3 factorial times x minus 0 cubed plus 0 times x minus 0 to the fourth plus 1 over 5 factorial x minus 0 to the fifth plus 0 times x minus 5 to the 6th power minus 1 over 7 factorial x minus 0 to the 7th power, and so on. So this simplifies to f of x equals x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus the general term, which is negative 1 to the n times x to the 2n plus 1 over 2n plus 1 factorial. So now let's try another example. This example says, write a third degree Taylor polynomial for f of x equals 1 over x squared about x equals 1. Taylor polynomials are very similar to Taylor series. Because this particular problem says write a third degree Taylor polynomial, we're going to take 3 derivatives of f of x. Then you're going to evaluate each of these derivatives at the center x equals 1. So f of 1 would equal 1, f prime of 1 would equal negative 2, and so on. Then solve for a sub n. A sub 0 equals 1 over 0 factorial, which equals 1. A sub 1 equals negative 2 over 1 factorial, which equals a negative 2, and so on. And then state that f of x is about the third degree polynomial of x, which is represented by p sub 3 of x, which equals 1 minus 2 times x minus 1 plus 3 times x minus 1 squared minus 4 times x minus 1 cubed.